Hello everyone, I would like to introduce an interesting project that we are doing at IIT Palakkad on automated lung ultrasound video analysis tool. This project has been developed as part of the COVID-19 initiative from IIT Palakkad. The first question that I would like to answer is why lung ultrasound? With COVID-19 in the recent past, emphasis for non-invasive imaging of lung has been gaining a lot of importance. And the gold standard for non-invasive imaging of lung is computed tomography or CT. However, the issue with CT is it is based on ionizing radiation, hence it's not very useful for periodic monitoring of the lung. Portability of a CT unit is limited, so bedside monitoring is really not practical. And most important aspect is disinfection is extremely tedious. And that's where lung ultrasound scores. Ultrasound is nothing but sound at high frequency, something like 1 megahertz and around, so it's not really ionizing. So this can be taken to the bedside, can be used for periodic monitoring, it can be used n number of times to monitor the health of the lung over days or even within a day 2 times or so. And dynamic imaging is also possible, which means patient is comfortable, they can be normal when the scanning is done. And most important, disinfection is very easy because it's just a portable unit. So why automated lung ultrasound? So I talked about the positives of ultrasound being portable, easy to disinfect, enables dynamic imaging, it's non-ionizing, etc. But one of the most important drawbacks for ultrasound is it's really not user friendly. It's heavily dependent on the user, the expertise of the user to take the scan and so on. So one of the important issues, as you can see over here, is ultrasound involves a lot of parameter changes while taking the scan. So that means real clinical expertise is needed. And not only that, once the images or videos are formed out of the machine, interpreting these videos and images also requires certain amount of skill. And that's where the artificial intelligence techniques evolved over the past few years can aid us and help us in sort of a real-time feedback as well as real-time assistance in taking an ultrasound image as well as interpreting the ultrasound image of frames which are coming out of the machine. Now with respect to COVID-19 or lung infection, how does ultrasound helps or how does ultrasound sees the COVID-19 infection? So from the studies done over past few years, it is very clear that the different states of the lung, from being a perfectly healthy lung to being a very unhealthy lung, the abnormality and the severity of infection, everything is clearly evident from ultrasound images or ultrasound frames in the form of crystal clear patterns. Something like A lines which correlate to a healthy lung, to something like B lines which is the start of infection, and something like lung consolidations which is the extreme condition where the subject has to be taken to ICU or ventilation, are very evident from lung ultrasound images and videos, and hence artificial intelligence techniques, particularly computer vision techniques, can be enabled to automate this process of identifying the health of a lung. Where the proposed approach or proposed package comes into the picture, and I would like to explain this in 3 steps. The first important step is actually the 14-point lung ultrasound scan. So when we say 14-point lung ultrasound scan is something which is established by the clinicians in the team, and this is something which is extremely important because lung is a fairly large organ covering on both sides of the body. So we have identified 14 points where the lung ultrasound will be performed, and each of these 14 points will contribute to a video. And this sort of covers the entire spectrum of lung, and that is subsequently used for all the analysis in this study. The next important step is actually the video summarization step. This is important because imagine a single point of lung ultrasound scan. We have 14 points, out of that a single point. If you think about it, a 30-second scan over 30 frames per second will contribute to something like 1000 frames of ultrasound video from a single point. So if you have 14-point scan, that means 14,000 frames. For a clinician to go through each and every frame and annotate or have some sort of classification on each and every frame of these 14,000 frames is humanly impossible and improbable, and particularly important when a scenario like pandemic where quick scan and analysis is required. And that's where the video summarization tool will help. It takes these 14,000 frames, or maybe point by, let's say, 1,000 frames, and identify the key frames in the video which are pathologically important and very relevant, which can be subsequently analyzed by an expert clinician. So almost like average 16,000 reduction in the number of frames is achieved using the proposed video summarization tool. Now the next important aspect, the key frames are identified. The next step is actually annotation of the important landmarks like A lines, B lines, consolidations, reaps, shadow, etc. So the annotation is an important task, and clinicians now need to look only at the key frames, not all the frames. And for this purpose also we have given a GUI tool to the clinician, and this tool is also having an underlying object detection model, an AI driven object detection model, which will automatically identifies the important landmarks in the lung, and clinicians only need to actually now maybe correct those annotations, or maybe those missing annotations they can remark it. And this tool also enables something like active learning. So this is extremely important, the identification of the landmarks. Once the landmarks are identified, we primarily use it for two purposes. One is to give an immediate feedback on the quality of the images acquired. So this is basically done as shown in the algorithm over here, where each and every landmark is weighted some value, and based on these weights we will say that the acquired frame or acquired video is of sufficient quality. If the quality is not sufficient, the immediate feedback is given to the clinician so that they can retake the scan there itself without proceeding for the further steps. Sufficient quality frames are available. The next important step is the severity scoring of infection of the lung. So for this purpose, we again, based on the landmarks identified, we have classified a given image or frame into 5 classes as shown here. Class 1 means an absolutely healthy lung, there is no issue with that. And class 5 means it's a very infectious lung, something like lung consolidations with a lot of tissue consolidations inside, where the patient is in a scenario where he has to be admitted to ICU or ventilation immediately. Once the severity scoring is done, we will display that to the clinician in a very novel way as something like a dashboard as shown over here, where each point of the 14-point acquired will be represented by a color, and the color basically means greenish means it's a healthy lung, and the reddish side means it's a really infectious lung. And what is the advantage of such a scoring dashboard is something like, let's say day 1 the scanning is done, the dashboard is available to the clinician. He can clearly see which region of the lung is more infectious, and for subsequent scans, maybe day 2 or even within the same day, only those points need to be retaken. This will take a lot of savings. I mean, this will basically save a lot of time and effort from the clinical side, as well as such a dashboard has been greatly appreciated by all the clinicians involved in this project. This is where I would like to conclude saying that the project is clinically evaluated, hence it is a technology readiness level 7 or 6, and it's ready for deployment. And our idea is to have a complete package where we have the clinicians acquiring the scan and the video summarization and the GUI tool available to them at the place of scan, and output of that will be some sort of initial scoring system which is again at the local place, but the same key frames which are identified can be taken over to the cloud for further processing and analysis, or it can be even deployed on a low-end GPU system like Jetson, Xavier, or so on. So this forms not just the AI algorithm but a complete package, where even we are planning to deploy the algorithms for even a legacy system which doesn't have traditionally a cloud or a mobile backend support. To the best of our knowledge, this is first of its kind effort in India where an automated algorithm with some complete package is being applied for lung ultrasound. There has been some work in CT and X-ray, but this is the first of its kind for ultrasound. And why ultrasound is important? Because it's not so popular in India. We can bring this technology to the rural parts where these imaging techniques are not really widespread there. And ultrasound being portable, being low cost, being affordable, and enables dynamic imaging, coupled with the AI technology that we are introducing, it can give more penetration to this modality, particularly in rural parts of India.